Hello, TADSummit 2020. Fernando here on behalf of PAIC Business Development. It's a pleasure to be back, and without further ado, let's start our presentation. Quick introduction to our company. We provide telecommunications and commerce and business solutions. Our products we will focus on the telecommunications on this presentation. And we call them extended products as we extend from open source software. The extended signaling gateway is a product we developed since a year ago, and we've added some cool features on top of it, a map and a cap proxy, an HTTP diameter gateway, an SMPP gateway, REST API enabler for SS7 diameter SIP SMPP. Then we have the extended GMC, which we will go through much deeper along this presentation. It's the focus of our presentation. Extended DRA, a diameter routing agent with some cool features like IMSI discrimination and IMSI-based routing filtering. Ability to prioritize routing to host and realm, destination host and diameter host and diameter realm, destination realm substitution and forwarding mechanism, fallback policy and multi-homing of multiple IPs, and load balancing routing. The extended SDP or service delivery platform, which has a service creation environment for voice, SMS, USSD, and geolocation applications, which we will go through it on a demo today. Built-in voice over IP subscriber network, multi-channel campaign manager, including social media integration, SIP call handling capabilities, billing, call routing, and call ringing, and a REST API to interact with third-party applications and external services, among many other features. The extended SMSC, which is basically a full power SMSC for mobile-originated, mobile-terminated short messages, with multi-tenancy for core networks connectivity, prepaid-based charging through diameter, all the encodings, supports binary, OTA, SMS, long SMS, and multi-protocol traffic processing, either SS7, SMPP, SIP, and HTTP. The extended USSD gateway is a USSD gateway with full support for mobile originated and network initiated USSD. It also has multi-tenancy for core network connectivity, multiple core network connectivity. It has USSD for the IMS. It's basically USSD over SIP as for 3GPP specification 24390. We also have a user-friendly service creation environment for faster time to market, and HTTP, XML, and SMPP APIs. Okay, that was coverage of our products, our extended products on the telco side. Our footprint, we have more than 30 happy customers, over 20 countries, with more than 90 platforms deployed. Our team is about 37 dedicated colleagues in more than 10 countries. We have 24/7 support because those 10 countries goes from the west coast of the Americas to India. So we follow the sun. This is our team. The names are there. We have the PAIC Innovators, which is the R&D team. We have mainly the team is based in Latin America, although we have also Alex in Spain and James in the USA. but most of the guys are based in El Salvador, Nicaragua, and Honduras. The commercial team is also based in Central America, but we also have people in Karim in Jordan and Tamir in Israel. The support team, it's widespread. It's a good mixture there. We have in Central America and in India and also in Africa, in Ghana and in Tanzania. And our administration team, which is mostly based in Latin America, in Honduras and El Salvador, basically. And this is us. So let's go for the presentation. I am Fernando Mendioroz. I'm the CTO of the company. And the presentation is about the Geolocation API. So our Geolocation Solution provides a geolocation API for real-time, transparent interaction with mobile networks for gathering location information from cellular radio networks. It has a global functionality, and it's independent of core or radio access network, device hardware, or software, operational in low-grade network conditions, such as underground or indoor environments. We provide a cloud-based API that allows service providers to integrate universal location data to any IoT application, triggering actions and responses from other networked devices and communication channels such as voice and messaging. The mobile location information can be retrieved autonomously or triggered by asynchronous events from messaging services such as SMS or USSD or voice, independently of underlying network infrastructure. And we can receive alerts upon entry or exit or being inside a predefined zone, geofencing basically, as well as alerts when certain devices approach zones within a predefined distance or motion events. Okay. GMC approaches some GPS-based application limitations, such as indoors and underground positioning. And also, it's user hardware and software independent. So by means of GMC capabilities, we can locate any mobile phone in the world. So the attainable location information we can gather with the GMLC, with extended GMLC, goes from the cell global identification to the location estimate, the user equipment geographical information, depending on the capabilities we have on the mobile core network, but at least some passive location information can be gathered, and also active location information if the capabilities are there. So the main characteristics of the extended GMLC comprise a REST API, SIGTRON support, SS7 map support, of course, a diameter over SCTP support for SLH, SLG, and SH reference points. This is to gather location information or to retrieve location information from an LTE network. JSON support, NLP support, home or visited PLMN location. We can gather roamer's location. So if the target is roaming, we can gather we can retrieve the location from the roaming network if there's a roaming agreement, of course, between the PLMNs. It's cloud ready. It's based on James Lee. It has a very high performance and high availability. We have active development and support. we build a modern front-end UI over Vue framework with maps integration. And we also have developed a geolocation API for retrieving location information or adding location information to services over voice, USSD, and SMS, and also IoT integration. So here we are showing the architecture and the heterogeneous networks topology. We can see the GMC software architecture in the middle. As you can see, we have the James Lee engine there, and some HTTP servlets, also MLP servlet for connecting with the GMC client or the Geolocation API through JSON, and the SS7 and the diameter connectivity to retrieving location information and subscription information from GSM, GPRS, UMTS networks through SS7 and diameter via diameter reference points, the same location information from an LTE network, and either if it's available 5G network through this SH diameter request, we can even gather 5G location information. So the capabilities that the GMC has, the most basic map anytime integration. We query the HLR and indirectly the VLR of the network, and we gather the subscription information containing the location information. And we also kind of hack, this is, we developed a provider scalar information. We need first to do a map SRI or SRI for short message, from which we get the routing information to send the provider scalar information to the VLR where the target is attached to. So through this method, we retrieve the subscription information, including the location information, plus the IMSI from the SRI, from the previous SRI. The most complex one in SS7 is the location service management operations, which include the routing information for location services, which is obviously directed to the HLR, providing the routing information, and then we send a provider scalar location. This is with intention to get the user equipment location estimate. For this, we need to have an SMLC and positioning methods like OTDOA or AGPS in the radio access network, and then through those positioning methods, we gather the user equipment location estimate and some other information that is retrieved by this method. Also, a very important feature of these location service management operations is that with provider scalar location, we can arm a geofence, an area event. So whenever the target gets inside, leaves, or keeps inside a predefined area, we can get a report giving other parameters like the event interval or the sampling. So we can get reports based on every event, and also periodic reports based on reporting interval and reporting amount. Okay, so an analogous method is of the latter is via diameter, and this is for an LTE network. Instead of send routing information for LCS and provide subscriber location and subscriber location reports over map, we have routing information request, provide location request, and location request location report request, sorry, over diameter, or on SLH and SLG reference points, this in an LTE network. So as with provide subscriber location, we can arm a geofence, an area event, but it's a little bit more powerful on diameter, because we can also, as for the 3GPP specifications, we can also arm a motion event. So based on a distance, we can get a location report. Also periodic location reports, and we can also, without a PLR, as without a PSL, we can get location reports on emergency call events, for example. We've also developed a simpler way to gather location information from an LTE network through the SH reference point and through a user data request. So if there are no capabilities like the OTDOA or AGPS or an ESMLC, we can gather location information through this method. Commercial applications, a lot of them. I will brief here. Security, for tracking location of people of interest and receive alerts when they approach, enter, or exit predefined areas. Retail, to send dedicated marketing and sales information based on proximity to retail establishment and sales location. Transportation, truck transportation fleet locations, receive alerts and deviation from preset routes, proximity to non-access zones, and pretty more. Policing, to track compliance of restricted people with movement restrictions. To notify about the whereabouts of a specific model subscriber, for example, the Family Finder application, or fleet management, workforce management, asset management, road traffic control and planning, next generation 911. Also to notify whenever a mobile subscriber enters, exits, or remains within a geofence. But the emergency call positioning, mobile marketing, mobile advertising, security, environmental warnings, notify if a certain mobile subscriber is located at a specific distance from a predefined location, for parental control, for core restraining order, for area terminal monitoring, location-based charging, network and business analysis. Of course, I'm briefing here. There are more commercial applications. For example, some MNO targeted use cases, business intelligence to enrich customer profile with location information with a timestamp, identify user positions to improve network coverage and network expansion with the objective to reduce deployment times and maximize investment on network expansion, improve point of sale location design and expansion with the objective of getting retail savings, improve marketing campaigns by subscriber location forecasting with the objectives to reduce churn and increase average revenue per user. To offer subscribers mobility advanced geographic information system to real estate companies and big retailers to improve new real estate ventures or retail shops expansion, The objective is to find other data monetization streams, such as smart cities related revenue streams also. And advertising for enable location-based marketing campaigns. So we can create geofences and detect which subscribers are within those areas in near real time. And enable then we can enable the MNO to send targeted SMS marketing campaigns to those subscribers within the geofence area. And the objective here is advertising agencies as potential customers. So we have the extended geolocation API here graphically. This comprises an ecosystem on which we have the extended GMLC, the extended SMSC, the extended service delivery platform, and the extended USSD gateway. So we can provide or enrich USSD, SMS, and voice services with location information. So the main objectives of the Geolocation API, extended Geolocation API, is to offer an API that web developers can understand without the need of any knowledge about the underlying telecom infrastructure and jargons, and thus make it easy as possible to include geolocation as a value-added feature in their applications. The API aims to gather mobile telephony subscribers' location from mobile network operators core and radio access network, either through S7 map or LTA diameter-based operations, which are very complex and difficult and very subjects for very experienced telecommunication and software engineers. So through the Geolocation API, we make web developers' life easier with telecom. And also for MNOs to monetize voice and legacy channels such as USD or SMS with location-based services. Some use cases: to notify about the current location of certain mobile subscriber, examples like NG911, Family Finder, the iWatch cardio activity alarm, etc. To notify about certain mobile subscriber entering, exiting, or being within geofence. Mobile advertising, emergency, and lawful use cases apply to this type of location-based service. To notify if certain mobile subscriber is within or has moved a certain distance from a specific location. And many use cases apply to this type of location-based service, like e-health, to indicate the nearest medical facility, to locate patients, pandemic geofencing. Actually, we've used the GMLC for throughout 2020, I can guarantee you that. Co-restraining order, when someone is legally not allowed to be within certain range of another individual, for parental control, to notify a parent when their children are farther than N meters away. Emergency services, alert with location on a compromising situation like an earthquake, fire, kidnapping. Location-based charging, top-up promotions, mobile advertising, hanging out. So we're going to go through a Geolocation API demo. This is a USSD trigger location-based emergency service with geofencing. So on this demo, the user will dial *911* a contact number hash, which will reach the extended USSD gateway, which will then contact the extended service delivery platform according to its routing rules. The Geolocation API is called to perform a map ATI to extended GMLC according to the logic of the project created by the extended SDP service creation environment. And once the Geolocation API retrieves the location information from the extended GMLC, it will perform another location request to the extended GMLC. And this will be through diameter SLH, SLG reference points. This is to arm a geofence to request a location report from the LTE radio access network, while they're requesting MSISDN exits the area given by the cell ID of the LTE cell ID or the EUTRAN global cell identification provided by the initial map ATI. So then the extended STP sends an SMS through SMPP to the contact number with the current location of the USSD requester. And this is for alerting and demanding assistance. And finally, the extended STP orders the extended USSD gateway to end the USSD session, informing the current location and the delivery of the SMS to the desired contact number. Moreover, we're going to do a location report as if the USSD requester has exited the area given by the EU Transcell Global Identification provided by the initial map ATI. So graphically represented here with some animation. So let's say that the USSD session initiator dials *911 star a number hash like this, which will reach the extended USSD gateway through means of map. Then the extended USSD gateway will translate that map message into SIG to get to the extended STP and call the Geolocation API according to its routing rules. The extended STP will, according to the service, the USSD service project created, will send an HTTP post to the extended GMC in order to carry out our location service by means of a map anytime interrogation to the HLR. The HLR will consult the VLR, and then the location information will be retrieved by the extended GMC and give back to the extended STP by answering the HTTP post. Then, by having this location information, the extended STP will execute another location request, but this time by means of sending a provide location request through diameter. So the HTTP post goes back to the extended GMC with other information, of course. And firstly, it needs to gather the routing information from the HSS through a ACLH routing information request, and then the proceeding provide location request goes to the EMEA. Then the rest follows whatever is going to happen on the SMLC, the evolved SMLC in this case, and the positioning method that is located in the radio access network, in the LT network, let's say AGPS or OTDOA or UTDOA, it will get back to the MME, and then the provide location request will be answered. And at this point, the post sent, the HTTP post sent with this purpose gets back to the extended STP. And now geofence has been armed. So when the USSD requester exits the area in which it was located when it requested the service, a location request, a location report will be delivered to the extended GMC. So finally, the extended STP will send an SMS through by means of SMPP and to the SMSC, and of course the SMSC will deliver through map to the network. The SMS will go to the contact number the USSD requester asks for, and then it goes. And finally, the extended SDP will demand the extended USSD gateway to finish to end the USSD session with the location information provided to the USSD requester, and also announcing that the SMS has been delivered to its contact. So that's it. And the next step will be the demo.